For years, the AI arms race focused on one thing: raw GPU power. Who could cram the most processing cores into a rack? But today, AI scale is constrained by something else entirely: the data bottleneck. We treat thousands of accelerators as a single supercomputer. When that supercomputer trains a massive LLM, every GPU must talk to every other GPU, sharing terabytes of data and gradient updates. If just one link stalls, if one packet is lost, or if one memory access is delayed, the entire trillion-dollar cluster stops. We call this the Straggler Problem. The solution is to build an AI nervous system, a fabric so fast, so optimized, and so lossless it makes the problem disappear. First, the internal fabric. Inside the server, NVLink and NVSwitch create a tight, non-blocking interconnect, uniting dozens of GPUs into a single, cohesive unit. Second, the cluster fabric. To connect racks, architects rely on the Clos topology, a massive, non-blocking leaf-spine architecture using high-speed RDMA fabrics like InfiniBand or specialized Ethernet. But even this speed is not enough. We must also optimize memory. The next step is memory disaggregation using CXL, the Compute Express link. CXL lets accelerators access a shared pool of DRAM outside their local server. It's critical for placing cold data in cheaper memory and reserving expensive HBM for hot data. And finally, we eliminate the biggest bottleneck of all: the CPU. Technologies like GPUDirect allow network cards and storage to DMA data straight into GPU memory, cutting the CPU and OS out of the hot data path entirely. This isn't just theory. Look at the NVIDIA GB200 NVL72 system. 72 NVLink connected GPUs in one rack, moving terabytes per second. It's a single machine dedicated to velocity. The next frontier is photonics. As electrical copper limits max out, systems like Google's TPU v4 are already using optical interconnects to link thousands of chips, achieving unprecedented scale and efficiency. The AI factory is built on three strategic layers: power, thermal management, and now, data logistics. The winner of the AI race will be the one who moves the most data most efficiently. In our final installment, we shift from the training floor to the deployment edge, analyzing the specialized architecture needed for real-time AI inference data centers.